Hello, excuse me. Hello, welcome back to Chapter 9, Section 9, where we're talking about the quadratic formula. Now, I really considered rearranging the order of the examples. I decided in the end just to keep it with the book because I thought that'd be confusing, but however, I am going to mention this because we've already been using the discriminant. I've already talked about it. But in this section, we're going to explore a little bit more about what it means. So, if you remember from the quadratic formula, and I'll pull this out again, this is the first sheet that I used. This is my quadratic formula. This part under the radical, in the first videos, it was a perfect square. I ended up with like square root of 49, and this problem was 7. In the second video, or the second example, we ended up with like the square root of 20, which is not a perfect square. The 20 is not a perfect square, so when I did this problem, I had to estimate it. Well, there's a couple other weird things about square roots. The square root of 0 is 0. And when I get to the quadratic formula, and actually it'd probably be good if I wrote it up here in the corner. So let me move this where you can see it. All right, so here's the quadratic formula again. Negative b plus or minus the square root of b to the second power subtract 4 times a times c over 2a. Now what we're looking at specifically is this part under the radical, not the square root of this, but under the radical. That is called the discriminant. And what that means is it separates the quadratic equations into, if the discriminant looks like this, this is what happens. If it looks like this is what happens. Those are the three things we're going to look at. All right? Now, if this is a positive number and it's a perfect square, then I end up with a quadratic equation that I could have solved by factoring or graphing. It would have been easy to do. And we'll talk about that in example 5. If it's not a perfect square, no problem, grab your calculator, estimate it. In Algebra 2, we will actually talk about what happens when we don't estimate it and we just want to simplify. But we'll save that for later. There's always another step. Keep that in mind. But we want to think about a couple things here. What happens if this equals 0? It's not going to happen very often, but what happens if it does? Well, the square root of 0 is 0. Why is that important? Because of the plus or minus. Adding 0 and subtracting 0 don't change anything. So like when we do the plus or minus, usually that means like positive 5, negative 5. Adding 5, subtracting 5. But positive 0, negative 0 doesn't make sense. 0 has no sign. It's not positive, it's not negative. 0 is just 0. Adding 0 or subtracting 0, same idea. So what ends up happening is that you don't get two solutions. More correctly, you don't get two different solutions. You end up with just one solution, which is the same thing twice. Then what happens if the number is negative? And we talked about this in the last section when we did completing the square, and maybe, and yes, and even in the previous where we did square roots. If you take the square root of a negative number, you do not get a real solution. You do get something, but we're not going to talk about that in Algebra 1. We'll save that conversation for Algebra 2. Again, there's always another step. So here's what we're going to do. I'll move that up so you can see the whole thing. We have 3 examples here, and they have it all worked out. So here's the b squared minus 4ac for each of them. They worked it out. The b is negative 4, the a is 1, the c is 3. They got 16 subtract 12, which is 4. If the discriminant is positive, you get 2 distinct. And distinct means kind of like they're different from each other. Distinct. 2 distinct real solutions. And if I graph it, that means my parabola crosses the x-axis in two places. So x equals 1 and x equals 3. Two of them. Sometimes they don't end up on nice grid lines. This one could have been solved by factoring. What two numbers multiply to give 3, add to give -4? It'd be x subtract 1, x subtract 3. So of course 1 and 3 are the solutions. Nice. But what happens if I get, like this example, if I get my discriminant as 0? So a is 1, b is 2, c is 0. I get 2 squared. They should use parentheses here. 2 squared subtract 4 times 1 times 1. That's 4 subtract 4, which is 0. The discriminant is 0. And when I take the square root of 0, I get 0. And when I add 0, it doesn't change this negative b. When I subtract 0, it doesn't change the negative b. So when this happens, I just get negative b divided by 2a. The graph of this is where the vertex is going to just touch the x-axis. So actually, instead of one real solution, you actually get two that are the same. Remember, you always get 2. How do I know I get 2? Because if I factor this, what two numbers multiply to give 1, add to give 2, that'd be x plus 1 times x plus 1. The same factor is going to give the same solution. It's just going to give it twice because I've got 2 factors. Finally, for this one, you work it all out. B squared subtract 4ac. Here's your a, b, and c. I end up with -4. And when I take the square root of -4, I don't get a real number. I get something, but that's a big step that we have to take when we learn about a new group of numbers. So we're going to save that for Algebra 2. In this case, you get 2 solutions with imaginary, and I don't like that word, but that's what everyone calls it, parts. But for our purposes, you can just say you get no real solutions. And even the word real is not a good way of saying it. Imaginary makes it seem like it's make-believe. It's not make-believe. Like, you don't talk about imaginary animals in biology. So all you need to do is find the discriminant and then decide what type of solutions you're going to have. And here's the steps. And don't forget, this means that they are going to be distinct. That's a fancy word for saying they're going to be different. This is going to be 2 that are the same. And I'm okay if you say no real solutions. That's what I want. However, this is 2 with imaginary parts. And again, imaginary. Don't like that word. Okay. So for this example, and I don't need to do a lot of work for these. All I need to do is find the discriminant. A is going to be 3, B is going to be 10, and C is going to be 2. So I do b to the second power. Don't forget to use parentheses. 10 squared. Subtract 4 times a, which is 3, times c, which is 2. Square this, multiply this, subtract. 10 to the second power, you know that's 100. 4 times 3 times 2. 4 times 3 is 12. 12 times 2 is 24. And 100 subtract 24 is going to be 76. This is a positive number. So I get 2 distinct real solutions. That's all you have to do, since that's a positive number. Let's look at the second one. My A is 9, my B -6, and my C is 1. B to the second power is -6 squared. Don't forget to use parentheses. Subtract 4 times 9 times 1. -6 squared is positive 36. 4 times 9 is 36. 36 times 1 is 36. And look what happens. I get 36 subtract 36. That equals 0. That's neither positive nor negative. So I get one real solution, but it's actually two that are the same. So they are not distinct. You get the same thing twice. Finally, for the last one, my A is 1, so is my B, so is my C. 1x squared plus 1x plus 1. I get 1 squared, subtract 4 times 1 times 1. This is 1, subtract 4, which equals negative 3. When it's negative, I get no real solutions. And I don't like the fact that they're hiding things from you, like this one and that one. You always get two solutions. Always. Sometimes you get two different solutions, like we've done for every problem we've done so far. Sometimes you get the same thing twice. And sometimes you get two solutions that are what we call not real. But like I said, we'll save this for Algebra 2. All right, we'll see you in the next video.